بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول درس جديد وهو بعنوان الازدواج في مادة الاستاتيكا. طبعا الازدواج ده موجود في الحياة اليومية والحياة العملية. كلمة ازدواج اللي هو القابل two forces قوتين متساويتين في المقدار ومضادين في الاتجاه ولكن بينهم مسافة، فهو بيكونوا ازدواج. الازدواج ده هو له عزم أو اسمه ذراع الازدواج وله اتجاه وله مقدار. المقدار بتاعه معروف ممكن نجيبه، واتجاهه معروف له اتجاهين، يا إما في اتجاه عقارب الساعة أو ضد عقارب الساعة. Welcome my dear student in our math program for second 3. Today we are taking new lesson in static. It's called the couples. What is a couple? Look at definition of the couple. My dear student, look at me. What is a couple and the problems about couple. Look at my dear student. Definition. What is the couple? It's a system of two forces are equal in magnitude, also in the opposite in direction, and acting in different line of action. My dear student, couple, system of the two forces equal in magnitude, opposite in direction, and the action in different line of the action is called couple. My dear student, don't forget two forces equal, opposite direction, but action in the different line of the action. This is called a couple. Moment of couple. Look at my dear student. We have two forces. The first upward F, second F downward, equal in magnitude, opposite direction, but action of the line different. This distance between AB, distance AB is L or arm of the couple. Direction of the couple in this case anti-clockwise is positive. Look at my dear student. Second is negative with clockwise equals moment of the first F times L, but the moment of the couple of the second equals negative FL. Why? Because direction of couple is clockwise. The moment, my dear student, of couple equals norm of BA times F. Norm. Why norm? It's moment. Value must be positive. Norm AB or BA times F equals AB F sin theta equals FL. Important rules. My dear student, F3 coplanar forces act on a rigid body and they are completely represented by sides of triangle taking in the same cyclic order. Then the system is equivalent to a couple. Important rule. If we have three forces act on the sides of triangle in cyclic order, we deduce that the system is equivalent to a couple. What is the magnitude of this couple? Magnitude of its moment equals ratio as the first magnitude. We find K ratio of the couple F over L, force over L. F1 over AB equals F2 over BC equals F3 over CA equals K. Constant. In this case, F1 act on AB, F2 act on BC, F3 act on CA. Therefore, three forces act on sides of triangle in cyclic order, and there is relation constant between force and each side, its value K. Example: ABCD is a parallelogram in which AB 12 centimeter, BC equals 8 centimeter. Measure angle A equals 60 degrees. Forces of magnitudes 6, 10, 6, 10 kilogram weight act along AB direction, CB direction, CD direction, AD direction, respectively. Prove that the system is equivalent to a couple and find its moment norm. How to prove that, my dear student? System equivalent couple. System equivalent couple if R equals 0 and the moment not equal 0. Look at the solution. ABCD is a parallelogram. Look at two forces 6 and 6 on AB and CD. This form couple. Also 10 and 10 force act on CB direction and AD direction. Angle A equal 60. In this case, my dear student, we have two problems. To find the magnitude of the moment of the car. What is the perpendicular between the force 6 and 6? DH. What is the value of DH? DH equal AD sine 60, X and 7. Also, what is the arm perpendicular from two forces 10 and 10? BE. What is the value of BE? Equals AB sine 6, AB equal 12. Therefore, my dear student, find the value of BE equal 12 sine 60, 6 root 3 centimeter. Also DH equals AD sine 60 equals 8 sine 60 equals 4 root 3. The two forces 10 and 10 form a couple. Its moment M1. What is the magnitude? Negative 10 times BE. Why negative? Because direction of the couple is clockwise. Equals negative 10 times 6 root 3 equal negative 60 root 3 kilogram weight dot centimeter. The unit of the couple, my dear student, equal unit of the force times unit of length, centimeter. The two forces 6 and 6 form a couple. Its moment M2. M2 equals 6 times DH. 6 times 4 root 3, 24 root 3 kilogram weight centimeter. This set force form a couple. Its moment M1 plus M2. We add negative 60 root 3 plus 24 root 3 equal negative 60 root 3 kilogram weight centimeter. The norm of moment must be positive, 36 root 3 kilogram weight centimeter. My dear student, now we are translate to another example. ABCDHO is regular hexagon. What do you mean regular hexagon? Is polygon form 6 sides are equal in length. and its angle also equal its measure of 120 degrees. ABCDHO is a regular hexagon, length of whose side is 8 centimeters. Forces of magnitudes 3, 8, 3, 8 kilogram weight at along AB, CB, DH, OH respectively. Prove that this system of forces equivalent to a couple and calculate its moment. Solution. My dear student, look at regular hexagon AB, CD, HO, ABH, measure angle ABH equals 60 degrees. Also, we have forces 3, 3, moment, a couple. What is the arm of the couple? HA. Length of HA equals what? Equal HB cosine or sine 60. Good. Because HA opposite measure angle 60. Opposite over hypotenuse equal sine 60. HA equals HB sine 60. My dear student, we calculate AH and BO. AH is the perpendicular between forces 3 and 3. BO length between two forces 8 and 8. Where AH equals 16 sine 60, 8 root 3 centimeter. Also BO equals 6 root 3 centimeter. Why, my dear student, BO equals 6 root 3 centimeter? Because we have length. If length equals BO 8 root 3 centimeter, BO equals 8 root 3 centimeter. Why? Because we have length of regular hexagon 8. Therefore, if the length of the AB and the AO 8, BO opposite angle 120. 120 when construct or make perpendicular from A to BO. This bisect angle A to 60 and measure B, in this case equal 30. Isosceles triangle bisect BO. BO equals what? BO, in this case we find the value of A of half BO equals AB sine 60. AB sine 30. After that, by substitution, therefore BO equal 8 root 3. Set of forces constant of two couples. 3, 3 with arm AH and M2 8, 8 with arm BO. By using, we say that this set of the forces is equal to a couple whose moment M. M equals M1 plus M2 by using substitution. Therefore, moment equal negative 40 root 3 kilogram weight centimeter. Another example. ABCD is a rectangle which AB 9 centimeter, BC equals 12 centimeter. My dear student, we have ABCD is a rectangle which AB equal 9 centimeter, BC 12 centimeter. An isosceles triangle is drawn outside the rectangle with base AD and height 8 centimeter. Forces of magnitudes 36, 48, 36, and 40 gram weight are applied along AB, AD, CD, DE, and EA respectively. What is the required? First, prove that system of forces equivalent to a couple and find the norm of its moment. Solution. Look at, my dear student, we have rectangle ABCD and isosceles triangle EAD, such as the base of isosceles applied on AD. We have forces 36, 36 form a couple. And look at, my dear student, the triangle EAD also form a couple? Yes. Why? Because if we divided each force on each side, we can form constant ratio. My dear student, in triangle EXD, measure x equals 90 degrees. Therefore, AE equals ED equals square root 6 power 2 plus 8 power 2 equals 10. The first 36 form a couple. Its moment M1 36 times the length 12 equals 432 gram weight centimeter. The moment of the couple of the two forces 36 which act on AB and CD, lengths between them 12 centimeter. The second, my dear student, the three forces acting along in triangle ADE in the cyclic order. Therefore, my dear student, we find F over L, the force 48 over 12 equals 4. In AD, 40 over 10 also equals 4. 40 act on DE and the length of DE equals 10. Also, the force 40 act in EA equal 40 over 10 also equal 4 is the value of K or constant ratio. Therefore, my dear student, the moment of the couple M2 equals what? The ratio multiplied twice area of triangle. The ratio equal 4. Area of triangle half base times height times 2. Therefore, answer is 4 times 2 times half AD times EX. Then, my dear student, if we find the moment of the couple of three forces act on three sides of triangle in cyclic order, the moment is K or constant ratio multiply twice area of a triangle. 4 times 2 times half times AD times EX equals 4 times 12 times 8 equals 384 gram weight centimeter. Therefore, the system is equivalent to a couple of moment M equals M1 plus M2 equals 432 plus 384 equals 816 gram weight centimeter. My dear student, Now we are translate to another example. ABCD is a trapezium which AD parallel to BC. Measure angle ABC is right angle 90 degrees. AB 8 cm, BC 17 cm, also AD 11 cm. Forces of magnitudes 22, 16, 34, 20 gram weight at along DA, AB, BC, CD respectively. Prove that system is equivalent to couple and find its moment norm. Then find the two forces was acting along AD-CB direction so that the system will be in equilibrium. Solution. Look at, my dear student. ABCD is a trapezium. Measure angle A, measure angle D are right angles. AD equals 11, BC equals 17. Look at, my dear student. AD equals 11, BC equals 17, therefore BH equals 11 and HC equals 6 centimeter. Also AB equals 8 centimeter. We find the value of DC by using Pythagoras theorem equal 10 centimeter. We know that, my dear student, cyclic order number 1, K equals 16 over 8. Why? Because look at, my dear student, in AB force 16, length 8. Also in BC the force 34 and length 17, ratio equals 2. Also DC the force 20, length 10, ratio equals 2. DA the force 22 and the length 11, the ratio equals 2. This is a constant ratio, then the system equivalent couple. By using the value, what is the value of moment of the couple? Before the set, this says forces of form a couple, moment equals the constant ratio times 2 area of trapezoid. This trapezoid or trapezium, what is the area? Base 1 plus base 2 over 2 times height. Base 1 equals 11, base 2 17 over 2 times 2 times what is the height? DH or AB, 8 centimeter. Therefore, the moment of the couple 2 times 2 times 11 plus 17 over 2 times 6, answer is 112 gram weight centimeter. My dear student, let the two forces B, F and F act on AD and HB. The couple, the moment of couple must be equal 0. Sum of moment of the couple if the two forces act in AD and HB, moment a couple must sum of the couples equal 0. Therefore, negative F times 8 plus 112 equals 0. Therefore, at F equals 112. Find the value of F. 112 over 8 equals 14, the value of the force F. Therefore, F equals 56 gram weight. Another example. ABCD find lamina in the form of rectangle in which AB equals 18 centimeter. AB equals 18 centimeter. BC equals 24 centimeter. And weight 20 Newton. U acting and intersection of its diagonal. Weight 20 Newton act on intersection of its diagonal. The lamina is suspended by a thin horizontal pin passing through smooth hole near the vertex D, so that its plane is vertical. If a couple, the magnitude of its moment is 150 Newton centimeter, and its direction is perpendicular the plane of the lamina and act on the lamina. Find inclination of dB to the vertical in the position of equilibrium. Look at solution. My dear student, look at lamina ABCD suspended from point D. Look at lamina is in equilibrium under two couples. Therefore, we say that the two forces 20 and R form a couple. Its moment 150. 20 downward or upward. 150 must equals 20 times OE. Therefore, we find the value 150 20 OE equals 15 sin theta. Therefore, my dear student, sin theta equals 1 over 2. What do you mean? Theta equals shift sine 1 over 2 equals 30 degrees. My dear student, by the end of the lesson, we know that what is the meaning of the couple. If we have two forces are equals in magnitude, opposite direction, but the action line are different, then is form a couple. And we know that we have two directions of the couple. Couple positive in anti-clockwise, but couple is negative in clockwise. What is the moment of the couple? Moment of the couple equals the value of F times L. F is the force, but L is the length of or length between the two forces. We know that the couple is very important in our life. My dear student, I am very happy to spend such time with you. Thank you